Hi everyone, Miss Lahoski here. So I'm going to be doing a review for the Eureka Math Module 5 quiz, which is getting posted today and due by 8 o'clock on Tuesday evening. So, I always do a review before we take an assessment. So I figured, even though we're not in the classroom, still have to be fair and provide it to you guys, of course. We want you to succeed and try your best, and we want to set you up and give you the tools that you need. So, of course, I'm not going to go over the actual test, but I will do a review with just different fractions. So I'm going to show you how to do the skill, but I'm not going to show you how to do the skill with the actual questions from the test, because that wouldn't be fair. I think you guys would agree with me. So number 1 says to draw a tape diagram and record the given fractions decomposition into unit fractions as a multiplication sentence. So I'm gonna do the example of 4/6. So the first thing that they want us to do is to draw it into a tape diagram. So I'm gonna draw 4/6. I'm gonna cut it into thirds, and then I'm gonna cut those thirds into half. That's gonna get me 6 pieces, and each one of these represents 1/6. Right? However, only 4 of them we have, so I'm gonna just kind of go like this, I guess. Cross out the 4. Now, to write that, to decompose it into unit fractions, well, a unit fraction is a fraction that has a numerator of 1. So if I'm going to be breaking out this 4/6 into unit fractions, it's going to be 1/6 plus 1/6 plus 1/6 plus 1/6. And written as a multiplication sentence, remember, because repeated addition, well, I should say multiplication is just a faster way to do repeated addition. So I would write that out as 4 times 1/6. Okay, so that is how I would solve that problem. Decomposing the fraction into unit fractions. See, 1/6 plus 1/6 plus 1/6 equals 4/6, right? And another way to rewrite that as a multiplication sentence would be 4 times 1/6. Okay, so that's the example for that one. Sorry, I'm working here with limited resources. Alrighty, so now let's move on to numero 2. It says to draw an area model for a fraction with units of thirds, fourths, or fifths. So I'm going to do it with sixths because it's not asking us to do that on the test. So I'm going to do it with sixths. So draw an area model. Okay, step number 1, draw an area model. Okay, remember, area model, area equals length times width. So I'm just going to draw a rectangle, and I am going to divide it into sixths. So let's see, I'm going to do into thirds, and then I'm going to cut the thirds in half to get 6, right? 1, 2, 3, 4, 5, 6. Okay, so step 1, I drew an area model for a fraction with a unit of sixths, right? 1, 2, 3, 4, 5, 6. Step 2 says to shade in more than 1. More than 1. Okay, so I'm going to shade in 2. 1, 2. So I just shaded in 2/6. So step 3 says to partition the area model again to find an equivalent fraction. Boys and girls, there's lots of ways we can find equivalent fractions. We did this in the beginning of March when we first started this module. We know that we can multiply the numerator and denominator by the same number. It can be any number in the world. Remember, any number in the world, as long as it's the same number, to create an equivalent fraction. In turn, you can also divide, and we're going to get to that once we get to the other side of the quiz. We can also divide to find an equivalent fraction. So for this, I am going to partition the area model again to find an equivalent fraction. So I'm just going to kind of draw another line like that. See how I'm partitioning it. And now I'm going to draw another line. So now I'm going to see what my new denominator is going to be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so my new denominator is 12. And I need to see how many of those 12ths are shaded. 1, 2, 3, 4. Okay, so 4 12ths of those are shaded. So let's see if this makes sense. Let's see if 2 6ths is equivalent to 4 12ths. I mean, quite honestly, boys and girls, that's a beautiful model. So it is right, but we're going to check our work and seeing if we can go from 2 to 4 and from 6 to 12 using the same number multiplying, we know we're right. So I have to think to myself, 2 times what number gets me to 4, and 6 times what number gets me to 12? Well, this is why, you know, boys and girls, we've been saying since the very first day of school, it is so important for you to know your multiplication, you know, facts. So I know that 2 times 2 is 4. And whatever I do to the top, I have to do to the bottom. And if 6 times 2 is 12, which it is, I know that I have successfully created an equivalent fraction. However, I know that we were also discussing the cross multiplication, the butterfly trick. You know, we're really shying away from using it. However, I can't tell you not to use it. I just can't. If it works for you, it works for you. The butterfly trick or cross multiplication basically says, I check it this way. 6 times 4 is 24. And 2 times 12 is 24. And is 24 equal to 24? Yes, it is, my friends. So now we know that 2 6ths is equivalent to 4 12ths. So that is how you would solve question number 2. Now we're going to move on to question number 3, which says, let me just look at my notes here because I'm making sure I'm not using the same questions. It says, determine which of the following are true number sentences. Correct those that are false by changing the right hand side of the number sentence. Circle whether they're true or false. All right, cool. So for number 3, I was going to do, I was going to compare 1/5 and 2/10. And I was going to say, are they equal or are they not? So either true or false. And if it's not equal, you have to change the right-handed side one to make it equal. So let's look at this. 1/5 and 2/10. If I want to draw a model, which is what we just kind of did for the question before, question number 2, and I'm going to section it off into 5 pieces to create my fifths. Okay, not exactly perfect, but 1, 2, 3, 4, 5. So I am going to shade in one of those fifths. Now, boys and girls, how do I get from 5 to 10? How can I make my model into tenths? I hope that you said I can cut it in half, because that is exactly what I can do. I would cut my model in half. And see, I'm not changing the size of the model. I'm just changing the amount of pieces that the model is divided into. So now it's divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So my new denominator is 10. And how many of those 10 are shaded? Oh, whoa, 2 of them are. So I would say, friends, that this number sentence is true. All right, so we do not need to change the right-handed side. And look, if I go from 1 to 2 by multiplying 2, and from 5 to 10 by multiplying by 2, if I do the same thing to the top and the bottom and my answer is correct over here, then I know I'm right. So this number sentence is true. 1/5 is equivalent or the same as or equal to 2/10. So now my second example is going to be 8/6. Uh-oh, Miss Lahosky, why are you doing this to us? Why are you giving us fractions that are greater than 1? Okay, so I am going to try to figure this one out. So I'm going to do something different. I am going to decompose these fractions and I'm going to compare them that way. So I know that if I'm going to pull out the whole of a fraction that has a denominator of 6, I know that that whole would be 6/6. All right, I'm going to draw my little 1. I've been doing it all along. I might as well stay with it. And what is my other fraction that has a denominator of 6? That 6 plus what would get me to 8? Well, I hope you all said 2, because you're right. 2/6 plus 6/6 gets you to 8/6. And 8/6 is the same as 1 and 2/6. I'm just going to kind of put that up there. So now I want to do the same decomposition for 5/3. So how many thirds would I need to have one full? Well, we know it would be 3/3. Now, what is the other third I would need to get to 5? So 3 plus what number gets me to 5? Well, if I start at 3 and I go up until I get to 5, it's going to be 2 more. So it's 2/3. So now we're basically saying that 5/3 is the same as 1 and 2/3. Now, I kind of like doing it this way, actually, because now what I'm comparing is 1 and 2/6 and 2/3, right? So, you know, I have this 1 here, and 1 is the same as 1. So I'm just going to kind of like forget about doing that, comparing the ones, because 1 is equal to 1. Now I'm just going to look at 2/6 and 2/3. Okay. So now, okay, what are some things I notice about these? The number sentence is saying that 2/6 is equal to 2/3. Is it true or false? Okay. So let's look at this. What are some things you notice and wonder? Well, I notice that their numerators are the same. I wonder which one is bigger. If I have a candy bar divided into 6 pieces and I give out 2 of them, or if I have a candy bar divided into 3 pieces and give out 2 of them, like which one is bigger, right? So I'm going to draw I'm going to draw 2 models, and I'm going to compare the models. I think I'm going to draw circles for this one. You can draw circles, you can draw rectangles.